54b in 3.2. So that is y equals f of x over x squared. I know you have no difficulties with this. Top function f prime times x squared minus f of x times 2x over x to the fourth. Yes, I will factor out an x f prime of x minus 2 f of x divided by x to the fourth because I want to simplify with one of these. So that's it. So the final answer is x f prime of x minus 2 f of x over x to the third. That's it. Now let's go back and take a look at 29. So in 29, they're asking us to differentiate this function. It just caught my eye when I was selecting problems. So this is in 3.2. So we have f of x equals x over x plus c over x. C is a constant, of course. We only have f of x. C is a number. So they're asking us to differentiate this. And I will say, well, wait a second. I know that I have to simplify in my life always, and I'm going to find the least common denominator, which is x. I'm going to multiply this by x, so I have x squared plus c. And I'm going to flip, and I get x squared over x squared plus c. This is what I'm going to differentiate, not this complicated thing. So then f prime of x, top function prime, times the denominator, minus the top, times the denominator prime, over x squared plus c squared. I'm going to try and simplify it. I don't know if I can, but I'm just going to distribute and see what happens. So these may go away. But I'm not going to play their game. They can throw anything at me without simplification. I will dictate for myself what I need to do, right? So this is 2x cubed plus 2cx and minus 2x cubed over x squared plus c squared. So this is 2cx over x squared plus c squared. And finally 3.1. In 3.1, I selected 3 questions, but I think one of them we already addressed. So I selected 42, 53, and 76 in 3.1. So let's see. Why did I select 42? Find the equation of the tangent line and the normal line. We can, if you want. Let's see what I selected 53. Yeah, we just did that. And the acceleration is the second derivative, so we don't need to do that. Let's see what I selected 76. Why did I select 76? At what numbers is the following function g differentiable? So I think we should start with 76. So 76 in 3.1. We don't need the 53. Okay, so we have g of x. They're giving us as 2x for x less than or equal to 0, 2x minus x squared between 0 and 2, and 2 minus x for greater than or equal to 2. Give a formula for g prime, and then sketch the graph for both. Fine. Well, g prime is very simple. I have 2 for x less than 0. I don't know if the function is differentiable at 0 for now. 2 minus 2x between 0 and 2. And negative 1, I don't know if it's differentiable at 2 for greater than 2. So this is for sure. Now, I don't know what happens at 0, and I don't know what happens at 2. If the function is differentiable at both or one or the other, I'll go back and close it. But right now I cannot. So this is the question. I don't know yet. If it is differentiable everywhere, then I will close both of them. If it's only differentiable here but not here, I will put the equal symbol where it belongs. And then we can graph. So first of all, I have to see if the function is continuous at 0. I know it's continuous everywhere. These are all polynomial functions, but I don't know if it's continuous at 0. I don't know if it's continuous at 2. So remember continuity at x equals 2. You thought you could get away? No, you can't get away from continuity. Okay, so the limit, I want to start with 0, sorry. 0. So limit as x approaches 0 from the left, from 2x. Does it, I don't know, equal limit as x approaches 0 from the right of 2x minus x squared, and does it equal f of 0? If all these are equal, then I say it's continuous. But I still don't know if it's differentiable yet, because we know a function is continuous at this point, but it's not differentiable. It's a cusp or a corner. So this is 0, this is 0, f of 0 is 0. So yes, it's continuous, but I still don't know if it's differentiable. I'm going to check 2 to see if the function is different. It's continuous at 2. So I have limit as x approaches 2 from the left of 2x minus x squared. Does it equal, so this was all yes. Yes, they're all 0. Does it equal limit as x approaches 2 from the right of 2 minus x, and does it equal f of 2? That I don't know yet. 4 minus 4, 0. 2 minus 2, 0. F of 2, 0. So the function is continuous everywhere. Now, is it differentiable everywhere? Now we're going to check. So differentiability, so this was continuity at 0, and this is continuity at x equals 2. Now differentiability at x equals 0. The limit from 2 as x approaches 0 from the left, does it equal limit from 2 minus 2x as x approaches 0 from the right? So this is 2. There is no one can do anything here, and this is 2. Careful, this means that yes, it is differentiable at 0. So I had to go back and put it in. Yes, diff at x equals 0. I'll do the same thing for differentiability at x equals 2. Limit from the left of 2 from 2 minus 2x. Does it equal limit from the right, -1? So 2 minus 4, this is -3. And this is -1. No. I will say it has to stay as is. Not differentiable at 2. Not differentiable at 2. So the function is continuous everywhere, but it's not differentiable at 2. Okay? So the formula for the derivative is here closed at 2, the equal symbol. This is okay, no change there. And here I cannot put the equal symbol because the function is not differentiable at 2. And now we can graph. Do I still have a minute? What time is it? Oh yes, I have 4 minutes. I can finish this, I think. So now let's graph. Okay. So 0 and 2 have to be in the table for sure. This is with 2x for the function, not for the derivative though, careful. So this is with 2 minus 2x, and this is 2x minus x squared, and this is with 2 minus x. Okay, so I have closed here, open here, closed here, according to these symbols. So for 2x, let's say -1, this is -2, with 0 is 0. With 0 is 0, with 2, 4 times 2 is 8, 4 minus 8, -4. With 2 is 0. Oh, wait, what did I do? It was continuous. It was continuous at 2. Did I do something silly here? No, 4 minus 4 is 0. So what did I do here? Ah, I know what I did. I know what I did. See? So what I wrote something silly here, because I know it's continuous, I already verified. So 4 minus 4 is 0. Careful, because we already verified that. It has to be continuous. So I have to let that dry. Okay, so it's 0 here, and let's say 3, -1. Good. So I can graph the function now. Please make sure you have enough room under this graph, exactly under it, to graph the derivative. So this will be g of x, and this will be g prime of x. Okay, so let me use a different color. Don't let me go over, because I'm not watching the clock right now. So 0, 0. So this is a line. Remember, I used 3 different colors just to make sure that my students remember they cannot graph. Okay, so this is 0. No, I don't want this. I want this. Okay. So at 2 is 0, and this has a maximum, and the maximum is at 1, so it's 1. Okay. This is the middle piece. Let me put it in blue just in case it's not clear. Okay. And then the other one, 2 minus x, 3, -1. Oh. So this is the function. Now, I know I have... Okay, time is up. If you want to leave, please do. I have to finish it. It's in the middle. I'm in the middle of the problem. So if you have to leave, I will post this, but I have to finish it. Okay, so I already know the derivative. So here it has closed and open. Here it's open on both sides. Okay, and here is -1 everywhere. Now here in the middle, I have with 0, I have 2, and with 2, I have -2, and that's what we got at -2, correct? I'm checking. No, on the left-hand side, aha, 2 minus 4, -2. Okay, that's correct. And on this side, it's still -1. And on this side, I have to have on the left of 0, yes, of course, 2. And at -1, It's 2, of course. And here I have 2 minus 2x. So for this piece is 2, for this piece is -1, and for this piece is 2 minus 2x. Okay, perfect. Okay, so the slope is 2, so it's this. Now here it's a linear function, and it goes to at 0. No, at 1. At 1 is 0. Okay. Good. Of course, at 1, right here. At 1 has to be 0 because the slope is 0. And on this side is -2. And of course, open. Okay, and it jumps to -1. All the way. That's it. So the slope here is 1. The slope of this function, quadratic function, is a line. And it has to be 0 at 1. Because the slope where the maximum is, the derivative crosses the x-axis. And at this point, the slope is -2. But then because it has a corner, the derivative is undefined. There is nothing I can put in here because on this side is -2, and on this side the limit is -1. And that's it.